Maddie?
What was the homework?
7.9.
7.9 only?
Yep, because the video cut out and I just kind of gave up on Friday.
Number 6. Oh, 7.9. I didn't understand your explanation on the answer key. Also, I found a couple of questions that were missing in previous stuff.
Where's 7.9? Am I at 7.9 yet? 7.7. Okay, what was the problem on 7.9?
Number 6.
Okay, so we've got acetic acid, right? And a whole bunch of stuff going on here. Let me see if I can get rid of all that. All right, so what happens with the addition of this guy? So if we add this in, remember that sodium is always soluble, right? So if sodium is always soluble, that means that this is going to exist as the acetate ion. Okay, so if I add more acetate in, right, that's going to shove this direction and form more of this material. Okay, if it shoves it that direction and forms that material, it's also going to be taking some of this with it. So if we decrease the amount of H3+, H3O+, if that gets reduced, then our pH goes up. Because remember what pH is it's a measurement of this, and it's like a reverse of if this goes up, that goes down. Okay, so pH, remember, is just a logarithmic scale. So if you have a pH of 5, that means that your concentration of this is 1 times 10 to the negative 5. pH of 5 equals this amount. Because if you do, what you have to do is you have to do the negative log of this to get pH. A pH of 3, 1 times 10 to the minus 3. So if you increase the amount of H3O+, you will decrease your pH. That number is going to go down.
Can you explain one more time about how the addition of the CH3C?
So this is the acetate, if that's easier to say. Okay. So if you add in acetate, right, that's going to force this to reestablish equilibrium by forming more of this material. Remember, at equilibrium, the rate of this stuff forming equals the rate of this stuff forming. So if you increase the amount of this stuff, it's got to shift this way to get back to equilibrium, to kind of get that balance back in. Because now all of a sudden you've got more of this stuff, so that's going to pull that this direction.
And you got rid of the sodium
because sodium, remember our SNAP? It's still going to be floating around in there, okay? But it's soluble in water, which we're in, aqueous, okay? So because of that, your sodium is going to be just floating around in there as a sodium ion, which means that this is also going to be floating around as an ion. So if that's floating around and we increase that amount of stuff, it's got to shift this direction and form more of this acetic acid. Does that help, Maddie, Grace? Yes? Okay. Anybody else still not understanding? You want to talk about that more? So this, when we're doing this, and talking about this, like increasing this, decreasing that, that sort of thing, that's all fine and good. It gives you kind of an idea of what your values should be, but we can actually do this mathematically and determine which way it's going to shift based on math. And that's what we're going to be looking at today. Any other questions on the homework? No? Good. Ready? Okay. Here we go. So, like I was trying to say Friday before the video cut out and I had to use a couple years ago's video, we're going to look at values of K and Q. Remember, K is your reaction quotient, your equilibrium quotient, and we've talked about how to find that before. Down here is kind of an example of what that looks like. Now, K is at a specific temperature, and that is at equilibrium. We can also then look at something called Q. And we talked briefly about this several units or several notes before. I think it was maybe 7.4. I'd have to look at that. But we talked about the idea of Q. And Q then is going to give you a snapshot anywhere in equilibrium. It could be at equilibrium. It could be before equilibrium. It could be after an addition of some material. You don't know where that's at until you calculate it. If it equals K, then you're at equilibrium. If it doesn't, you've got to figure out which side of equilibrium you're going to be on. Now, this goes through kind of a complicated way of determining which direction it's going to go. I have a much easier way. And you will see in most people's way of doing this, they always talk about Q first and then K. What you're going to want to do is you are going to want to take K, and you're going to do this alphabetically. K comes before Q. All right. Then you're going to take your values. We have our K value here, 3.5 times 10 to the minus 4. We have our Q value, 1. Then I'm going to do a greater than or less than. Which is greater than?
1.
Q. Yep. So I'm going to do that to show which one's greater than. And then I'm going to add a tail to it. And this is going to tell me which way my reaction is going to run. So when I'm doing this, that means I am going to form more reactant versus product to get that to reestablish equilibrium. So if we are looking at the equation here that they have, which is right here, all right, which one are we going to form? A, more of A or C based on this information? A. And we're also going to form more B as well. Okay. So the reaction is going to run this way to establish equilibrium and get it back there. So that means when we are doing our math down here, okay, we are going to add X here. We are going to add 3X here. We're going to subtract from here and here. I think it's easier to use the arrows and do that. Now, you can use logic. You can read through all the stuff and use logic, but my method's a much faster. And what you're going for on the AP exam is speed, yes? All right, so at equilibrium, we're going to do 1 minus X, or plus X, excuse me, 1 plus X. We're going to do 1 plus 3X. we are going to do 1 minus x and 1 minus 2x. All right. So, So our plug in the KC value and solve. Okay, so we know our KC value is this, which is 3.5 times 10 to the minus 4. We're going to take our products, 1 minus x, 1 minus 2x. We're going to multiply those together over 1 plus x. Oh, I should have squared this. Bad, Lippy. And then 1 plus 3x cubed. And you have a equation solver on your calculator. You can plug this mess into that equation solver and come out with the answer. Okay. If you don't know how to use your equation solver, come and see me and I'll show you how to set that up. Let me see if I've got. I wish I had. I've begged for years to get a calculator simulator so I can put my calculator up on the screen for you guys. So let's see. Math. Yeah. So if you click on the key on your calculator that says math, it is 2 down or 3 down on the left-hand side. Okay, so you have second, alpha, then math. Then use your toggle up thing to get to the bottom of the list because it'll circle back around and it's faster to go that way. And it says B, solver. And that's where you're going to find that guy at.
My piece says piecewise.
Mine also says that.
Would it be C, numeric solver?
Maybe.
Yeah.
Okay, so maybe it's numeric solver. Life can't be easy. All right, math. Yeah, mine says numeric solver, and it works on this newer calculator. I'm not getting it to work on this guy, the more ancient model. But what you do is you put in, once you get that going, then you get E1, that's this side of the equation. And then E2 is going to give you, you're going to have to put in this side of the equation. And you have to have quite a few parentheses on the bottom down here to get that to work. But you can get it to work and it'll solve it for you. And then you don't have to do all of the fancy math for it. To get your X's right next to the button that says alpha, that's where you get your X's from. Okay. And you can just spend a little time playing with your calculator at some point and figure that out.
Is this an L or no?
That's an L.
Okay, that's what I figured.
12 molar HCl.
That's what I figured.
What did you get for your answer?
Yeah.
Oh yeah, you want my answer?
Yeah.
Let's see, 0.446. So X should equal 0.446.
I also thought that's cool.
Yeah. Let me guess. You had to go to Quick Trip and get your map out.
Yeah, I did.
We have the exact same thing. There's high school stuff. It's going to be late, so might as well be extra late and go get food.
Yeah, exactly.
All right,
Late is late.
Riley.
I didn't get your X value.
I also did it. I got X equals.
I did.
I got X equals 10.
Yep. So you guys are going to have to become one with your calculators and practice. Okay. Do you have the things raised to the proper exponents? Do you have the right parentheses in? What? 0.446. So maybe you have some setting in your calculator wrong. It could be, though, there should be little bottles back there that you can put some of that in. I don't want them pouring it out of the jug. That's scary. Should be in the acid cabinet. So there may be radians versus degrees. There's lots of different things that can get you off on your answer, settings and such. So, well, like I said, we're gonna have to play with it. I don't want to take up like lecture time to play with. We'll have time to play. I want to finish the discussion. Okay. Do you know how to set this up properly to figure out which way this direction is going to run? Do you know how to set this up properly? We can play with the calculators later, okay, and try to figure them out. The thing is that they're never going to give you a situation where you have to use that. So we're not going to spend that much time in class on it because they're not going to do that to you. They're going to give you a way to solve these without having to do it, okay? All right. So we've got reaction mixture here, 25 degrees Celsius, okay? Initially is going to contain PI, the pressure for I2 is going to be at 0.1 atmospheres. So we are going to put our initial pressure here. And our initial pressure of Cl2 is the same. Oh, it looks like it's the same for all the way over. Okay. All right. So find the equilibrium partial pressures for this temp. All right. So we know at K that we're here. We've got to figure out which way this is going to run based on these. So we have Q equaling. Is this reaction balanced? Not down here. Okay, they balanced it up here, but when they went to write it down here, they didn't have it balanced. Okay, so Q is going to equal 0.1 squared divided by 0.1 times 0.1. What is 0.1 times 0.1? 0.1 squared. Yes? Am I right? You're correct. So if we think of this as 0.1 squared, and this is what I was talking about. They're going to give you problems where you don't need to use that equation solver. So what is this? 1. Okay. So now we are going to write in alphabetical order the letters K and Q. We're going to write down the numbers for K, which is 81.9. We're going to write down our number for Q, which is 1. Then we're going to figure out which one is greater. K. So we're going to put our greater than sign in. And then we're going to add a tail. And that tail is going to tell us with the arrow which way this reaction is going to run. So it is going to form more of this material.
Hi. Do you have time to sign something for me, Clay?
Yeah. All right. So we are going to add 2x here.
Just for Key Club.
We are going to add x here. And we are going to add x here.
It's right there. There's something I did for Keto. Thank you.
Okay, so our equilibrium, our equilibrium is going to be 0.1 plus x, 0.1 plus x, and 0.1. Oops, I shouldn't have had this as a plus. No, I should have. That should have been a plus. These shouldn't have been pluses. Oh, Lippy. We just said that we were going to more products. I guess I can't sign something and do lecture at the same time. My apologies, everyone in here. I am not capable of multitasking. We said that we were going to form more products. So that means we're getting rid of some of this material. So these have to be minuses. So this is going to be 0.1 plus 2x. Good? Did I lose anybody there? All right. So we know our value for K. Yes? So 81.9 equals this guy. And what are we going to do to him? Square it. These are both the same values, so I can write them one time and do what to them? Square them. Now, get that written down and let's talk about how we're going to solve this without having to do as much math. Okay? You ready? You ready? You ready? I am going to take the square root of this side. And I'm going to take the square root of this side. That means 81.9 is going to equal 0.1. I don't need that, I guess. 0.1 plus 2x over 0.1 minus x. I took the square root of both sides, so that got rid of the squares here.
Why did the square root not carry on to the 81.9?
Because I'm an idiot. And that's why I always make mistakes, because I don't pay attention. All right, so we are going to clear this guy. We are going to Mathy out of here. Clear. I can't get out of here. How do I get out of here? There, I got my calculator back. Okay, we're good. All right, so the square root of 81.9 is 9.05. There we go. Okay, now you just do your fancy little algebra that you've been doing since 6th, 7th grade. For a lot of you, anyway. And you should end up with x equaling 0.0729. Then you just have to plop that back into here. So 0.1 minus that is going to end up giving us 0.027. And here we're going to end up with 0.246. What are my units? ATM. Very good. Okay. We talked about ATM up here with our starting values. That's what we're running with all the way down through here to get to that point. All right, good. Questions? Fun times? That's as bad as the equilibrium problems are going to get for this unit. No. Unfortunately, Unit 8, it's...
They get a little crazy.
That's what Ben says. Is that which one? What?
Yeah.
Remember when he said that?
All right, let's see this guy. We are going to calculate Q to figure out which way it's going to go. And then we're going to solve for our equilibrium concentrations. Okay. All right. So we've got our Q value. Q is going to equal our, and they did this as, okay, so this is where our arrow is here. They've got our equation balanced down in the table this time, so that's nice. All right, so we've got 3.2, and we're going to square that, times 1.85 divided by 2.5. So our Q value ends up being 7.58. I want you to set this up and figure out how you're going to, I want at least through here, okay? I don't know what that's about. We're not going to worry about that. What?
What if the arrow be the different way?
Yeah, you goofed.
Because 120 is bigger than 7.5.
Oh, God. Is it Monday?
Yes, it is.
Well, these are easy to fix. All right. So this is bigger than that, obviously. So then this turns into a minus. And these are going to turn into pluses. I guess I should look at my answer key instead of trying to figure it out in my head. All right. Did you get x equaling 1.5?
I got it as 1.4.
Close enough. Yeah.
How did you get the X?
Here. I put it into my equation solver. So I put the 128 equals, I'm going to have my products on top. So 3.2 plus 2x, and I got to square that, times 1.85 plus x over 2.5 minus x. And I put it into my equation solver, and I got that value.
Is that on your calculator?
The equation solver, yeah.
Got it.
We talked about that, but you were getting coffee,
Is it like a
so.
program?
It's
I
not
was.
under math.
I slept through my alarm. That was. Is it like a program on like the TI or whatever?
Yeah, well, it's not a program. You go to math.
Let me see. Watch if I get 10.
So you're going to hit math.
And I get 10 too. It's okay. I get
And then if you hit the up arrow, it comes to numeric solver.
There's a solver. What? Okay.
And then you just enter in the one side of the equation and the other side of the equation and hit solve. And it solves it for you. Derek, you look perplexed.
Can I see a calculator?
From like 3 years ago? No.
It's a numeric solver.
Yes, Maddie.
Oh, yeah, I got X equals hard again.
You got 3, she got 10.
What's
Well,
wrong,
I could
Maddie?
get 1, let's try.
Yeah, but parentheses are another calculator.
I
Two different equations.
I got 10 again. Yeah,
oh,
something's not right.
I
She keeps getting 225.
I don't know.
Where's the same answer from the previous time I tried?
I got 0.4.
Are we all getting the same wrong?
Okay, to be fair, I'm not.
Wait, no, I
I'm
still
not
got
100%
10
sure it's my fault. I have to mess with my settings way too often.
See, I get scared.
I
Go to
don't
settings.
think I messaged my
I got error, no sign change.
Because I'm like on a quest, don't know these, and I'm like scrolling through trying to figure out how to solve it. So that's
It's the same thing. I've already
and
messed
that's how you end up.
What?
there's my calculator.
Oh,
I got
well, wait.
1.496 blah 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 blah.
I got
I know. I know. I have to wait for the whole.
Maybe it's because she put parentheses in.
I don't know.
All right, so that's what you should come up with, and that's how you do K versus Q. And we are done with this part of equilibrium. The next part that we do is solubility,
Wait, oh,
equilibrium, and we will get into that next week or later this week. You got a lab tomorrow. You need to have that pre-lab ready